prove that n factorial plus 2 is divisible by 2 for every integer n greater than or equal to 2. Now, the first thing I would say is that since n is greater than or equal to 2, then we can say that 2 divides n factorial. That's because n factorial in the expanded form would be n times n minus 1 times n minus 2, all the way until we get to 5 times 4 times 3 times 2 times 1. So since n is greater than or equal to 2, n factorial, which here's my expanded form here, has to be divisible by 2 because this number here, 2, has to be in this expansion. Now, it could be that 3 is not in this expansion, and that would be true if n equals 2. But since n is greater than or equal to 2, the number 2 has to be in this factorial. So that means that n factorial is divisible by 2. So that means that n factorial equals 2 times k for some integer k. So now we can rewrite n factorial plus 2 as 2k plus 2, and then we can factor out the 2 as 2 times k plus 1, which is even, because k plus 1 is an integer. So that means that n factorial plus 2 is even. Now part B is going to be just like part A. So since n is greater than or equal to 2, n factorial, which here's the expanded form of that, is divisible by k for all k equals 2, 3, all the way up to n. And we can go through the list here to show that. Here's 2, here's 3, here's 4. We can pick any of these values all the way up to n for our k, and we can show that k divides n factorial. So that means that n factorial equals k times x for some integer k. So just like part A, then we can say that n factorial plus k is equal to k times x plus k. And we can factor out that k to get x plus 1 times k, which is divisible by k since x plus 1 is an integer. And those would be my proofs. Thanks everyone, and I'll see you in the next video.